Butterflies are often seen as symbols of beauty, delicacy, and transformation. At first glance, they seem harmless, tiny insects drifting through gardens on fragile wings. But appearances can be deceiving. Hidden beneath those colorful scales are some of the most extraordinary abilities in the entire animal kingdom. One butterfly becomes almost completely invisible without using camouflage. Another can travel thousands of kilometers across continents using a brain smaller than a grain of rice. Some fool predators into seeing the face of a much larger animal. Others create dazzling colors without using a single blue pigment. And one species has inspired scientists developing the next generation of optical technology. These aren't myths. They aren't special effects. They're real butterflies with real superpowers. Let's begin. The butterfly with transparent wings. The butterfly. Imagine walking through a rainforest and watching a butterfly fly past. You notice its orange body, its dark wing borders. But strangely, you can see the forest directly through its wings. It almost looks unfinished, as if someone forgot to color it. This is the butterfly, one of nature's most remarkable optical illusions. Unlike almost every other butterfly, the central part of its wings is almost completely transparent. At first, scientists assumed the wings simply lacked color. The truth turned out to be far more fascinating. Butterfly wings are normally covered with thousands of microscopic scales that reflect light in every direction, creating the brilliant colors we associate with butterflies. The is different. Large portions of its wings contain far fewer scales, and the exposed surface is covered with millions of nanoscopic pillars, so small they are invisible to the human eye. These tiny structures prevent sunlight from reflecting. Instead of acting like a mirror, the wing allows light to pass almost straight through it. The result is extraordinary. Against the constantly changing background of leaves, branches, and sunlight, predators struggle to distinguish the butterfly from its surroundings. It doesn't disappear completely. Instead, it blends into whatever lies behind it. This makes tracking its movement surprisingly difficult for birds and other hunters that rely on visual contrast. Its transparency is even more impressive during flight. Because the background changes every fraction of a second, predators have very little time to focus on the insect before it vanishes into the visual chaos of the rainforest. And humans are paying close attention. Engineers have studied these antireflective nanostructures while developing improved camera lenses, solar panels, smartphone screens, and medical imaging devices. Millions of years before humans invented advanced optics, a butterfly had already solved the problem. The butterfly that drinks tears. Blue Morpho menelaus. Most butterflies spend their days visiting flowers. They drink sweet nectar, pollinate plants, and move quietly from blossom to blossom. The blue Morpho doesn't always follow those rules. Instead of searching only for flowers, it sometimes lands directly on turtles, caimans, tortoises, frogs, or even sleeping mammals. Then it begins drinking their tears. As strange as that sounds, this behavior serves a very important purpose. Rainforests are full of sugar-rich food sources, but sodium is surprisingly difficult to find. Butterflies need this mineral for healthy muscles, proper nerve function, and successful reproduction. For male butterflies especially, sodium becomes an extremely valuable resource because part of it is later transferred to females during mating, increasing the chances that their offspring will survive. Scientists call this behavior puddling. Many butterflies gather minerals from wet soil, riverbanks, or animal droppings. The blue Morpho simply takes the process one step further. Animal tears contain dissolved salts that provide exactly what the butterfly is looking for. Fortunately for the animal, the butterfly causes no harm. Its delicate proboscis acts like a tiny drinking straw, collecting the salty moisture without damaging the eye. Some researchers have even observed groups of butterflies patiently waiting for large reptiles resting near rivers. As soon as the opportunity appears, they move in. It's one of those moments that seems almost impossible to believe. A creature famous for its beauty, quietly harvesting minerals from the tears of a crocodilian. Nature rarely follows the rules we expect. The butterfly that lives for months. Monarch Butterfly. Most butterflies live surprisingly short lives. Depending on the species, many survive only 2 to 4 weeks after becoming adults. Just enough time to reproduce before their life comes to an end. The monarch butterfly breaks that rule completely. Every autumn, a special generation emerges unlike any other. Scientists call it the Methuselah generation. Instead of reproducing immediately, these butterflies undergo dramatic physiological changes. Their reproductive organs remain inactive. Their metabolism slows. They store enormous reserves of fat. Almost every part of their body shifts from reproduction to survival. Why? Because they are preparing for one of the greatest migrations on Earth. Some monarchs travel more than 4,000 kilometers between Canada, the United States, and the mountains of central Mexico. For an insect weighing less than a paperclip, the journey is astonishing. Even more incredible, no single butterfly completes the entire annual migration cycle. Several generations work together like runners in a relay race. One generation begins the journey. Another continues it. A third completes the return. Only the final migration south is carried out by the extraordinary long-lived generation. These butterflies can survive for 7 to 8 months, nearly 10 times longer than many other butterfly species. Scientists are still investigating exactly how monarchs navigate such enormous distances. Evidence suggests they combine the position of the sun, an internal biological clock, polarized light, and even Earth's magnetic field to maintain their direction. All inside a brain no larger than the tip of a pencil. Sometimes the greatest superpower isn't strength. It's knowing exactly where home is, even when it's thousands of kilometers away. The butterfly that looks exactly like a dead leaf. Indian leaf butterfly. At first glance, there's nothing unusual about it. With its wings spread open, the Indian leaf butterfly displays brilliant shades of deep blue and bright orange that make it stand out among the vegetation. But then, it lands. The wings slowly fold together, and the butterfly simply vanishes. What remains no longer looks like an insect. Instead, it looks exactly like a dry leaf that has fallen from a tree. Not just in color, in shape, in texture, even in the tiny imperfections. The pointed tip of its wings resembles the stem of a leaf. Dark lines imitate veins running across the surface. Small patches look like mold or insect damage. Some individuals even appear to have little holes or decayed edges, making the illusion even more convincing. This is one of the finest examples of cryptic camouflage ever discovered. Rather than hiding behind objects, the butterfly becomes the object. Birds search for movement, outlines, and familiar shapes. But evolution has erased almost every clue that would identify this butterfly as prey. To a hungry predator scanning hundreds of leaves, the butterfly becomes nearly impossible to notice. Researchers have found that predators often overlook the butterfly even when it's sitting in plain sight. Not because the camouflage is merely good, but because the brain automatically classifies it as something completely uninteresting. This is known as masquerade camouflage. Instead of blending into the background like a chameleon, the butterfly convinces the predator that it isn't an animal at all. The illusion becomes even stronger because the butterfly chooses where it lands with incredible precision. It often settles among real dead leaves that match its exact size and color. The surrounding environment completes the disguise. Perhaps the most remarkable part is knowing what lies hidden underneath. The instant it opens its wings, the dead leaf disappears, replaced by a vibrant tropical butterfly that seems impossible to miss. Two completely different identities. One extraordinary survivor, the butterfly that scares predators with giant eyes. A peacock pansy. In nature, sometimes surviving doesn't require fighting. It simply requires making your enemy hesitate. The peacock pansy has mastered this strategy. Most of the time, it rests quietly with its wings closed, remaining relatively inconspicuous among grasses and shrubs. But the moment danger approaches, everything changes. The butterfly suddenly spreads its wings, revealing 4 enormous circular markings. To us, they look like beautiful patterns. To many predators, they look like eyes. Huge eyes. Eyes belonging to a much larger animal. Birds hunting insects rely on extremely rapid decisions. They have only fractions of a second to determine whether something is safe to attack. The sudden appearance of what resembles the face of an owl or another predator interrupts that decision-making process. Instead of attacking immediately, the bird pauses. Sometimes it jumps backward, Sometimes it abandons the attack altogether. That hesitation may last only a moment. But for the butterfly, 1 second is enough. It escapes. Scientists call these markings ice spots, and they have evolved independently in many different butterfly species. The Peacock Pansy possesses some of the most dramatic examples. Experiments have shown that predators are significantly less successful when butterflies display large ice spots compared to individuals whose markings have been hidden. The illusion doesn't need to fool every predator forever. It only has to work once. There's another advantage. Even when a predator does attack, it often aims for the large false eyes near the outer edges of the wings rather than the butterfly's body. Butterflies can survive surprisingly large tears in their wings. Damage to the body, however, is usually fatal. So even a failed illusion can redirect the attack away from the butterfly's vital organs. It's an extraordinary reminder that in evolution, fear itself can become a weapon. The butterfly that pretends to be poisonous. Viceroy Butterfly. Imagine looking exactly like one of the most dangerous butterflies your enemies have ever learned to avoid. That's the strategy of the Viceroy Butterfly. At first glance, it appears almost identical to the famous Monarch Butterfly. Both have bright orange wings crossed by black veins. Both display similar patterns while flying. To many birds, they seem indistinguishable. For decades, scientists believed they understood the explanation. The monarch feeds on milkweed as a caterpillar, storing toxic chemicals that make adult butterflies taste terrible. Birds that eat one monarch quickly learn a painful lesson. Avoid orange butterflies. The Viceroy seemed to be exploiting that reputation. If predators already feared monarchs, simply looking like one would dramatically increase its chances of survival. This became one of the world's most famous examples of mimicry, where a harmless species imitates a dangerous one. Then researchers made a surprising discovery. The Viceroy isn't completely harmless after all. Experiments showed that many predators also found the Viceroy unpleasant to eat. Instead of one species deceiving predators, both butterflies reinforce the same warning signal. Scientists now classify this relationship as mimicry. Two different species. One shared message. Don't eat us. This benefits both butterflies because predators learn the warning much more quickly. Every bad experience strengthens the lesson. The Viceroy proves that survival isn't always about becoming stronger than your enemies. Sometimes, the strategy is allowing someone else's reputation to protect you. And in this case, that reputation became so convincing that it fooled scientists for generations. The butterfly that crosses continents. Painted lady, Vanessa. Imagine weighing less than a single sheet of paper. Now imagine crossing an entire continent. That is the life of the painted lady butterfly. Found on every continent except Antarctica, this remarkable species performs one of the longest insect migrations ever recorded. For many years, Scientists believed these butterflies simply moved short distances following the seasons. But modern tracking techniques completely changed that idea. Researchers discovered that some populations travel thousands of kilometers, crossing deserts, mountains, and even stretches of open sea. One migration route can extend from tropical Africa to northern Europe and back again. That's a journey of well over 10,000 kilometers when the complete cycle is considered. For comparison, if a human matched that achievement relative to body size, it would be like walking around the Earth several times. Of course, no single butterfly survives long enough to complete the entire cycle. Instead, the migration becomes a relay race spanning multiple generations. One generation flies north. Their offspring continue even farther. Another generation pushes deeper into Europe. Eventually, new descendants begin the long journey south once again. None of them has ever made the trip before. Yet somehow, each generation continues in the correct direction. Scientists are still investigating how painted ladies navigate such enormous distances. Evidence suggests they combine the position of the sun, internal circadian clocks, wind patterns, polarized light, and possibly Earth's magnetic field. It's an astonishing level of navigation for an animal with a brain weighing less than a milligram. Their migration also plays a crucial ecological role. As they travel, they pollinate thousands of flowering plants across multiple ecosystems, connecting habitats separated by entire countries. To us, they're beautiful visitors in a garden. But from nature's perspective, they're tiny long-distance travelers, helping entire ecosystems remain connected. The butterfly that flashes electric blue, blue Morpho menelaus. Few animals on Earth produce a color as breathtaking as the blue Morpho. When sunlight strikes its wings, an explosion of brilliant metallic blue suddenly appears. It almost seems to glow. Yet something extraordinary happens when the butterfly changes direction. The blue vanishes. From another angle, parts of the wings become dark brown, blending surprisingly well with the forest. This isn't magic. It's physics. If you examine the wings under a powerful microscope, you wouldn't find blue paint. Instead, you discover millions of microscopic scales, built like tiny layered Christmas trees. These structures manipulate incoming light through interference and diffraction. Only certain wavelengths, primarily blue, are reflected toward your eyes. Every other color passes through or is scattered away. Scientists call this structural coloration. It's completely different from ordinary pigments. Pigments absorb some colors and reflect others. Structural colors are created purely by the physical interaction between light and microscopic architecture. This is why the blue Morpho never fades in the same way painted surfaces do. As long as those microscopic structures remain intact, the blue continues to exist. Researchers have spent decades studying these wings. Their discoveries are helping engineers design anti-counterfeit banknotes, security holograms, highly efficient optical sensors, advanced display technologies, and new materials that generate color without dyes. Perhaps even more remarkable is how the butterfly uses this ability. During flight, every wing beat produces flashes of brilliant blue, followed by sudden darkness. To predators, the butterfly appears to blink in and out of existence. The constant flashes make it extremely difficult to predict its exact position. A beauty becomes confusion, and confusion can mean survival. The butterfly that looks like an owl is owl butterfly. A few insects can intimidate predators. The owl butterfly is one of them. When resting, it keeps its wings tightly closed. Suddenly, what appears before you doesn't resemble a butterfly anymore. Instead, two enormous circular markings stare back like the eyes of a giant owl. The resemblance is so striking that early naturalists believed it couldn't possibly be accidental. Modern research suggests they were right. Many birds instinctively avoid large forward-facing eyes because they often belong to predators. Even if the illusion lasts only a fraction of a second, that hesitation may be enough. But the deception goes even further. The surrounding patterns resemble feathers. The curved wing edges create the outline of a bird's face. In dim rainforest light, where details become difficult to distinguish, the illusion becomes surprisingly convincing. The owl butterfly increases the effect by remaining almost perfectly motionless. Predators don't have time to inspect every detail. Their brains make rapid decisions based on familiar shapes. And one familiar shape often means danger. Interestingly, these butterflies are most active during dawn and dusk, rather than bright daylight. The low light conditions help strengthen the illusion because predators see broad shapes more easily than fine details. Scientists believe this timing is another adaptation that improves the effectiveness of the false eyes. It's one of evolution's greatest psychological tricks. The butterfly never needs to become an owl. It only needs predators to wonder. What if it is? Sometimes, uncertainty is the strongest defense of all. The butterfly that creates color without pigments. Morpho Butterfly, Morpho. The most extraordinary butterfly superpower isn't venom. It isn't camouflage. It isn't migration. It's something even more fundamental. The ability to create color without using color. The Morpho Butterfly appears brilliantly blue. Yet if you crushed its wings and analyzed the material itself, you wouldn't find blue pigment. In fact, there is almost no blue color present at all. The famous blue exists only because of billions of microscopic ridges covering each wing scale. These ridges are arranged with astonishing precision, smaller than the width of a human hair. When sunlight strikes them, different wavelengths interfere with one another. Only blue light is reflected efficiently, and everything else disappears. The color isn't painted onto the butterfly. It's created fresh every single moment that light touches its wings. damage those microscopic structures, and the blue instantly vanishes. Nothing remains. Nature has effectively engineered a living optical device. This discovery has fascinated physicists, engineers, and material scientists for decades. Researchers are copying these nanostructures to build better security features for passports and banknotes, highly efficient sensors, advanced medical imaging systems, low-energy displays, and even self-cleaning materials. All inspired by an insect drifting silently through the rainforest. It's a reminder that evolution isn't just about survival. Sometimes, it creates solutions so advanced that humanity spends decades trying to understand them. One of the most beautiful colors on Earth isn't really a color at all. Butterflies may appear delicate, but hidden beneath their fragile wings are technologies that scientists are still struggling to understand. Transparent wings that almost erase their outline. Migrations spanning entire continents. Perfect disguises that transform insects into dead leaves. False eyes capable of frightening predators. And microscopic structures that create brilliant colors without using a single drop of pigment. Every one of these abilities evolved through millions of years of natural selection, proving once again that reality is often far more extraordinary than fiction. So, which butterfly surprised you the most? Let us know in the comments. And if you enjoy discovering real creatures with unbelievable abilities, make sure to subscribe too, because there are still countless real superpowers waiting to be revealed. Nature never stops surprising us,